So let's make that word count script even better. So if you remember from the last lecture, one of the big problems we had is that the words we were extracting out of the book weren't always words. Sometimes they had punctuation attached to them, and there was uppercase versus lowercase stuff going on. So we ended up with things where a word followed by a comma would be treated as a different word than a word followed by a period or a word followed by a space, because all we were doing before was breaking up strings of paragraphs by space characters and taking anything in between the spaces as a word. So we can do better. So there are natural language processing toolkits you can get. One's called NLTK, for example, that will automatically go out there and apply very complex algorithms for actually normalizing words and trying to figure out synonyms of words in different cases and things like that. But let's not go there just yet. Let's just do something a little bit better that's probably good enough for our purposes, and that's going to be using something called regular expressions. And you've probably come across regular expressions in some other programming you've done in other languages. It's basically a compact language for defining ways of splitting up strings into substrings using a set of compact rules. So this gives us a more robust means of identifying words within a string, taking that punctuation into account. So let's take a look at what that code looks like using Scala and Spark. So back to the Scala IDE here. We have up still our previous script where we just split out all of our paragraphs based on space characters and treated everything within the spaces as individual words. And, well, that produces okay results. It's not great. I mean, just looking at this right here, we have entrepreneurs followed by a comma being counted as its own word. Not okay. Parking with a question mark, that's going to be a different word from parking without a question mark. Let's at least fix that, shall we? So go up to the com.sundogsoftware.spark package, right-click on it, import from the general file system option there. And again, we'll browse to where we downloaded the course materials. For me, that is C downloads Spark Scala. And we should see a word count better.scala file. So let's select that and import it in. And take a look at that. So about the same amount of code, but this time we're using something called a regular expression. How does that work? So it's actually quite simple in Scala. What we're doing here is the same sort of basic work. We're setting up our log level, we're setting up a Spark context, we're reading in the book one paragraph per line, and then we're calling flatmap again to split up our paragraphs into individual words. But instead of just splitting on a space character, we're splitting on this regular expression. So if you call split with 2 backslashes, that indicates that I have what's called a regular expression. And there's entire books on regular expressions. If you're not familiar with them, I encourage you to go take a course on regular expressions or pick up an O'Reilly book on it. But short story is it gives you a syntax for more complicated ways of splitting up strings. And in this case, we're using the syntax uppercase W plus, which is just telling the regular expression, split this string up by words, and there could be more than one of them. So the uppercase W means I want words, however you interpret a word to be, Mr. Regular Expression Engine, and the plus means there can be one or more of them. So this returns back a list of words that takes punctuation into account, and returns back a new RDD of words that is a little bit more robust than the one we started with before. Now the other thing we're going to do is normalize everything to lowercase. So if you see here in my original results, ideas and stick in uppercase would have been counted as different words than ideas or stick in lowercase, or even where the first letter was capitalized, say at the beginning of a sentence. So let's fix that too. We're going to convert everything to lowercase so that these get counted as the same words and case doesn't matter. So that's all this map function is doing. And now in this case, we do have a one-to-one relationship between the words that we extracted from each paragraph and the lowercase versions of each word. So we're going to use map instead of flatmap for this one. And from that point, we can do the same thing we did before, called count by value, to get the number of distinct occurrences of each word that we ended up with after it's been stripped out by words and converted to lowercase, and print out the results. So let's go ahead and run that, see what happens. Go up to run configurations, and we'll create a new Scala application. We're going to call this word count, caps lock, word count better. And the class is going to be com.sundogsoftware.spark.wordCountBetter. Let's run that and see if we do indeed get better results. Off it goes. And we're done. And look at that. Sure enough, everything's been converted to lowercase, which is a good thing. And I'm not seeing any weird punctuation either. I'm not even seeing any weird Unicode characters or anything. So this is looking a lot cleaner, just by using this little regular expression instead of a space character and normalizing everything to lowercase. So, in addition to, working on an example and making it better and better by iterating on it, this is also an example of where you really need to look at your output data and ask yourself, is this really the result that I expect or want? A lot of times your initial attempt to write an algorithm for solving a problem in Spark doesn't quite yield the right results in the end. And you really need to look at your results and ask yourself, does this make sense? Are there edge cases that I'm not dealing with? Is my data somehow unclean, right? I mean, data cleansing is often just as much, if not more work for a data scientist's job as actually processing the data. So what we're really doing here is cleaning up our input data before we process it with count by value. And the whole point of this lecture really is to stress how important that can be. You need to make sure you have good, clean data. There's not a lot of outliers in it that might mess you up, and we're doing the right thing here. So anyway, you can see things are looking pretty cool, pretty clean here. The word technical appeared 11 times. The word addresses appeared 7 times. Product 182 times. Wow, I talk about products a lot. In fact, the book is mostly about building products. So that's cool stuff. So, we're getting closer here for sure, but we're still not quite where we want to be. This would be a whole lot more useful if the results were sorted, right? If I could actually see what the most popular words were and the least popular words more easily. And if I were to just sort this as it is, though, it's going to sort it alphabetically by word. So how do I get it to sort by the word count instead? Well, there's a few tricks we can do for that. So let's explore that in our next lecture.